Hi, my name is John Paul Raj, and my mission in life is to make the learning of math fun. So, if you're new to this channel, please do consider subscribing. On this video, I'm going to show you how to use the Nspire CX2 to solve some of the basic questions on algebra of vectors. Let's start. For the purpose of this demonstration, I'm using the non-cast version of the Nspire CX2. So we're going to go ahead and add a calculator page. Now, vector is also represented as a column matrix. And if you go to the templates key out here, you've got a row matrix, a column matrix, a 3x3 matrix. In fact, if you go via the menu, then option 7 is matrix and vector. The first one is to create a matrix. And here, if you go to matrix, it will ask you for the option, number of rows, number of columns, and you can easily enter 2 rows and 1 column and enter a column matrix. That means for a vector, you can define a vector even this way. Nothing wrong with that. However, the Nspire has its own notation and representation of vectors. So I'm going to show you that version. All right. So let's go and define some vectors here. The key that we're looking for is control the left parenthesis key. Okay. So it looks like a 1 by 1, a single element matrix, but that's the notation for a vector. Okay. So if it was a vector with 2 components like x and y component, x being 1 and y being 3, you got to enter it as 1, 3. Okay, x component being 1 and y component being 3. It looks like it's in rectangular brackets, but we get to this thing by going control and the left parenthesis. But when you say enter, okay, it gets defined like this. Now this looks like a row matrix, and the vectors are conventionally represented as a column matrix. So this needs to be, this is what I told you, you need to be careful. This is how the Nspire has been programmed to for vectors. So it is still a vector. It is not supposed to be a row matrix, all right? So that's the x component and that's the y component. In the same way, if you were to define other vectors, a vector b as control, remember this key to the control and the left parenthesis key, that will give you this template for a vector. And let's say this was something like a -4, comma, don't forget that comma, and 5, all right? So you've got a vector with x component -4 and the y component is 5, all right? So you can even enter a vector of with 3 components, x, y, and z, and comma, comma, and that should be the x component, the y component, the z component. You can do that way also. And once you defined your 2 vectors, now you can do any of the algebra of vectors, okay? You can just say a plus b. You want to looking for the vector a plus b, and when you just say hit enter, it will give you the vector a bar plus b bar, which is 1 and -4 giving you -3. That's the x component of a bar plus b bar. 3 and 5 giving you 8, giving you the y component of a bar plus b bar. And the same way you can do a minus b, and you hit enter, and that should give you the vector a bar minus b bar. And if you're looking for, let's say, the magnitude of a vector, then you go to menu, matrix and vector. Under that, you're looking for something called norm. Okay, norm refers to the magnitude of a vector. So you say norm of a will give you the magnitude, and that's in decimals. If you want, you can convert that into an exact value if it's required as an exact value. That's the magnitude of vector a bar, and in the same way you can get the magnitude of the vector b bar also. All right, you can get the magnitude of vector b bar just like that. It gives in decimals. That's the non-cast problem, but the cast should give you in an exact value. In the same way, if you were looking for a unit vector along a vector a bar, all right, so if you go matrix and vector. Now, for unit vector, what I suggest is just go down the arrow and this last part called vector, and there are options here for unit vector, so that you can choose unit vector along a bar, and that'll give you the unit vector along a bar. Again, you're seeing the decimals here, all right? You'd rather want to have exact values here. So that's where you find the unit vector. So in the same way, I'll show you again, matrix and vectors. You go down to the vector option, unit vector along, let's say, a bar plus b bar, okay? And there again, you will see it in decimals, but remember, it's better to give it in exact values. You can also convert this into a fraction if you're looking for, okay? That's in the number option. You can go number and convert to approximate fraction and get the exact value that way if you're using the non-cast version, that is. What are the other options available to us? You can go and do scalar products or dot products of the 2 vectors that you've defined, okay? So let's say you go to menu, matrix and vector, and let's just go down to vector, and you can say the dot product you're looking for. The dot product is found by a bar comma b, okay? Again, comma, and you hit enter, and there you'll get the dot product, which is a scalar, right? Dot product, that's why it's called a scalar product. In the same way, you can even find the cross product, okay? So go to matrix and vector, go down, and you can find the cross product of the 2 vectors. All right, and that's kind of interesting to note that the cross product of a bar and b bar is giving you a vector with three components x, y, and z, because it's going to be a vector that is perpendicular to both. All right, in a different plane altogether. So that will be an interesting thing for you to have a discussion in class. Now, this is how you do all the elementary algebraic operations for vectors. What I'd like to show you is how you can use a widget to do all these operations, how you can create a widget for vectors and do all your vector algebra just like that. And for that, what we're going to do is that we're going to use the CAS, because that's always a bit cool, right? So here I am on my CAS Nspire CX2. And what I'm going to do is that the first thing is I'm going to go and add a notes page, because the notes page I find to be a bit more cooler than the calculator page, all right? Especially when it comes to widgets. So what we're going to do is that we're just going to call it vector algebra. All right, so the name of the notes document, if you want, you can just, this is all just making it look pretty, as they say. All right, just close that. And then maybe even the color can be changed. The text color can be something in green. And there you go. So now let's define our vector. Let's insert a math box for that. And we say the vector A is going to be defined as, we are going to use this left parenthesis control, and let's just say we are going to have a three component matrix vector this time, x, y, and z. So it's going to be like something like 2, 3, and 4. Then a vector b can be defined as, remember, don't forget this one, control and the left parenthesis for the vector, that is. Okay, so let this be something like -1, comma 0, and 11. That's the vector b. Let's have a third vector also defined. So don't forget this one again. What should we call it? 0, comma 2. Don't forget the comma also. All right, and 9. There you go. So we've got three vectors defined, and so we can reduce the space, and maybe right after this we can enter a line saying do not edit below this line. All right, so that's just making it look like a nice pro widget. All right, so I'm just going to change the font, not the font, the format, the text, that is. Okay, and then change the font color. The color of the text, let's make it red so that stands out. Now let's go and do some algebra. So we're going to say the a plus b, a bar plus b bar vector, sorry, and that is going to be, that's the sum of the two matrix vectors, that is. Okay, so we can write down sum of a and b, and this should be remember, this should be emphasized at vectors, and since we can do this, all right, to denote it as a vector, so I can just make it bold here, and the same way I can make this bold here. Some textbooks have this bold notation for vectors. Okay, I'm just making use of that idea here. So sum of the vectors a bar and b bar is 1, 3, 15. And in the same way, we can say dot product, not inside the math box, dot product of a bar and b bar. This time we can copy this, and I'm just going to paste that here. And then we can insert a math box, and there we can say menu calculations, come to matrix and vector, make your way down to vector, and there we have the dot product. There you go, the dot product of a bar and b bar. That's going to give you the dot product. If you want to find the angle between the two vectors, so first let's just write down the formula. The angle should be the cos inverse. So I'm just going to go trig and cos inverse of a certain ratio. Is that right? And the ratio is the dot product up there. So let's just go into the dot product again, and calculation, matrix and vectors. I'm sure you could have copied that earlier thing down. So the dot product of the two vectors a comma b, and then the divided by the magnitude of the two vectors, so that is the norm, remember. So we come down to matrix and vectors, find the norm. Where's that norm? Norm is not here, sorry. Norm is on the, norm is here. Yeah, it's outside of the vector. That's interesting, huh? That the calculation for norm is not within the vectors. So norm of a and multiplied by the norm of b. Just remember that, okay? The calculation for norm, which is the magnitude, is not in that option for vectors, it's just there for matrices under the matrices option. So there you go, norm of B. So this thing now should give me the angle between the two vectors. Okay, and so if you want, you can just even write down that as a text, the angle between, let's see whether we have that text still copied. A bar and B bar. Oh, there you go, we have it. And I'm just going to make this normal. And format text. Can I just clip this off? Yep, it becomes normal. There you go. So we've got these things, and now let's just take off the calculations. Let's see whether we can make it look pretty, as they say, math box attributes. Let's just hide the input. And so there you go, sum of A bar and B bar is this, dot product of A bar and B bar is this, and the angle between the two vectors is this. Let's give a little space here. Is oops, not each, is. All right, and I'm just going to make sure that we've got everything right, just right. And should we say degrees here, so that, all right, and let's change that also. I don't know why it's defaulting to bold, that is. Okay, there you go. So I've got everything I want. Okay, the third vector was just put there if there was any other calculation, but I just wanted to show how you can use even the widget to do something like this. Make sure this just got one document. Okay, so make sure that it's just one document, otherwise you'll have to group it. So now you can go and save this document, file, and say save as, and remember we need to save it in the widgets folder. So I'm just going to go down to my widgets, and we can call this, I had already tried this thing out earlier. So let's just what should I call it? Okay, let me just call it angle between, or should I just call it vector algebra? Vector algebra. There you go. And I save it, and it's saved. Now let's go and add a widget, and we'll say we want to do that vector algebra. Where's that? So let's just go and open that widget, and here we go. We've got that thing. And remember, the first thing to do is to evaluate it, okay? Because you should be able to see everything in the green, the calculations in green. So what you're going to do is hit Control A or Command A and go to Menu, Actions, Evaluate. That kind of activates. This is the green I was talking about, okay? So the notes page is now activated. Now, depending upon whatever question you have, let's say since we've programmed the widget for a 3 by or a vector with 3 dimensions, like, but you have a question with only 2, okay? So let's just change it to 2 x and y components. So let's just make it -3. And 5, that was a vector A, and look at that error, dimension mismatch, because you can only add 2 vectors with the same dimensions, right? So obviously the question was with 2 vectors of the same dimension, which was 0 and let's say 9 for B. Once you do that, you've got the sum, the product, and the angle between the 2 vectors. I think this is really, really cool. Not just the fact that we learned how to do the vector algebra using the Nspire CX2, but also how we could use the Nspire CX2 to make a widget for such calculations even on vectors. If this video was useful to you in any way, please let me know in the comments below. I'm going to see you all in the next video.